This is Module 7, Investigation 3, representing circular motion. So we're going to do number 1, number 2, and number 6. A bug sits on the end of the fan and blades as the blade rotates in a counterclockwise directions. The bug is 2.6 feet away from the center of the fan. It is located at the 3 o'clock positions as the blade begins to turn. So number 1, we're gonna thinking about the quantity. What quantity might you track to represent the location of a bug as it sits on the tip of the rotating fan blade? List as many as possible. So first of all, you can think about this. Okay, so since the fan is rotating, the bug is actually traveling. So there is a traveling distance in the circular motion, right? But once you come back to the place that it was, and then it turned back again, right? So there's still the distance though. So there's a distance that we can think about. Distance that the bug travels in feet. But also, while the bug is traveling, since it's a circular motions, so when the bug was in the 3 o'clock, and then now it's 12 o'clock, and then it turned 90 degree. So there are also the measure of the angles. Subtends the path travel, but the measurement for the angle could be the degree or the radian. Then you can think about more. There's also the constant distance, which is from the center of the fan to the location of the bug, which is 2.6 feet away, which is wherever the bug goes, it still stays at 2.6 feet, right? Yeah. So there's another. This is the varying quantities, but we also can find the constant quantity. All right, number 2. So let's see the problem to answer the number 2. So number 2A, explain how the bug of vertical distance. We only looking at the vertical distance this time. Okay, so let me erase the stuff. So we are only looking at the vertical distance. So vertical distance. This is also the vertical distance. Vertical distance as where we were. Okay, so we are thinking about change to the clock from the 3 o'clock, 12 o'clock, and 9 o'clock, and then 6 o'clock. Alright, vertical distance is a view in the diagram above the horizontal diameter change as the bug travel from. So we are using the horizontal diameter from the diameter, okay? Alright, so first one, 3 o'clock position to the 12 o'clock positions. So 3 o'clock to the 12 o'clock, so 3 o'clock was actually the zero vertical distance, but at the 12 o'clock, it's actually went up to the 2.6. So for the 3 o'clock position to the 12 o'clock position for the vertical distance, it is actually the increases from 0 to 2.6 feet. Now we can think about 12 o'clock to 9 o'clock. So 12 o'clock to the 9 o'clock, but 12 o'clock was 2.6, but the 9 o'clock is now become 0, isn't it? So we can say decreases from 2.6 feet to the 0 feet. And then third one, the 9 o'clock position to the 6 o'clock position. So 9 o'clock was 0 feet as a vertical distance because it won't go up or down. Now go to the 6 o'clock, which is it go down to the 0, right? So we can say it is decreases from 0 to negative 2.6 feet, which is kind of weird to say negative, but it's below the 0, okay? And then from the 0 on the 6 o'clock to the 3 o'clock, which means it's all now the increases from negative 2.6 to the 0 feet. Now the B. As the buck travels from the 3 o'clock position to the 12 o'clock position, so which is, they're talking about 3 o'clock position to the 12 o'clock positions, how does the angle measure swept out by the fan blade change? So in here, the buck travels from the 3 o'clock to the 12 o'clock position. The angle measure that is swept out by the fan blade changes from, actually in here, this is starting place, right? So we're going to call the 0 radian, and then go up to here, which is a 90 degree, but 90 degree into the radian is a pi over 2. So changes from 0 radian to pi over 2 radians. Okay, but this is what I'm talking about, angles. And then C. For the successive equal changes of the angle measure from the 3 o'clock to the 12 o'clock position, how does the corresponding changes in the vertical distance change? So identify these changes on the diagram of the situation. So they're talking about this. So let me use a different color on there. So if I use the maybe the green. All right, so I'm gonna actually making a nice circle around the location of the buck. Okay, and then I'm gonna divide 3 o'clock to the 12 o'clock, the equal distance. Okay, so let me see. I wanna make it half first. Okay, and then I wanna make it another half. You know, I can go further, but you know. So we were thinking about the vertical distance. The vertical distance means this is a vertical distance. This is a vertical distance. This is a vertical distance. And this is actually the vertical distance. So you only need to check for the size of the vertical distance about here, to about here, to about here. So in here, what do you see as the bar to here, to here, to here? I can say this one is actually the vertical distance is actually the decreases. So we can mean that this is going to be the longest vertical distance, and then the getting shorter and shorter, as you see here, right? And then D, create a graph to illustrate how the buck vertical distance above the horizontal diameter measured in a feet could vary with the measure of the angle theta swept out of by the buck's fan blade measured in radian. Plot the points using the axis to illustrate how the angle and the vertical distance could vary. So what I can do is I want to put that as a horizontal axis as a theta, which is in radian. And then the vertical is gonna be the vertical axis is the vertical distance of the book. And then I'm gonna make the every 4. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, and 1, 2, 3, 4. Okay. So the first one I want to say 90 degree pi over 2, and pi, and 3 pi over 2, and then the 2 pi. And then I get the 5 pi over 2, which is same as pi over 2, and 3 pi same as a pi. 7 pi over 2, and then the 4 pi. And then since the highest the vertical distance it can go is 2.6 is less than 3. Okay, so I want to say every 2 unit is a 1. You also go down to the negative 2.62, so I need to get the negative distance too. So at the 0 degree was the vertical distance was a 0, right? Which is at 3 o'clock position, right? And then the pi over 2, it went up to the 2.6. And then pi becomes 0 again. And then 3 pi over 2 is going to be negative 2.6. And 2 pi is 0. 5 pi over 4 is another 2.6. Repeated it, isn't it? So the graph is repeating. So you'll see this graph. Okay. All right. But we're only using the vertical distance in this time. Okay. So next page. E. How will your graph in D changes if the radius of the fan is 3.9 feet instead of the 2.6? But only things you can think about is here, since now your bug is instead of 2.6, you have a bigger fan, so it's a 3.9 right now. So now bug is right here. So which is it makes a bigger circle, right? Motion, circular motion, but still the angle does not change. So because of that, the maximum and minimum of the graph will be 3.9 feet and then negative 3.9 feet. But the angle is going to be stay the same. And then I'm going to skip the f and g this time, okay? All right, then now it tells us the sine functions. So sine function is a circular, the circle is the center at the origin of the coordinate plane, and the angle with in its vertex and the circle's center has initially ray positioning at the 3 o'clock positions, and terminal ray rotates the counterclockwise. Called the point where the terminal ray intersects the circle, the terminal point. The function that represents the initial point is a vertical distance above the horizontal center, which is measured in radian length or radii. In terms of the angle rotating the measure is called the sine functions. So sine function is about the vertical distance through the vertical distance to the radius. So the sine functions we represent is the vertical distance over the r, which is come out as, you can find the sine theta. Okay, now there was also the cosine function. So difference is the cosine function is actually the horizontal distance is horizontal distance to the right of the vertical axis. Okay, so which means vertical distance means how much distance up to here, and then from the r, isn't it? So if I'm using it, so here, so this is one x and r. Okay, so cosine function is about the horizontal distance, which is x, and then the over the r. That's what we call the cosine functions. So I will do number 6, which is right here. So use a figure to answer the question. So approximate the measure of the data in radian. So in order to figure out the radian, we have to actually use the inverse functions. So in order to find the data, then you can use the sine functions or cosine function. It's going to be the cosine inverse of x over r, or theta is the sine inverse of y over r. So approximate the measure of the data in radian. So in order to find out it, which is you just need to know for the data. Now also you need to know this. So when you have actually the arc, I think I already talked about this. When you have an arc, right? So this we call the S, and then data, and this is R. Always a data. Oh, the arc, it measures always same as R times data, but data is in radian though. So in order to do the data, we just put the S over R. But the problem is, it's hard to actually measure this because it's in the curve, isn't it? And then we are looking for data. So I think I want to use this functions, okay? So in order to find the data, which is sine inverse of y is about here, right? Which is 3, right? Oh, no. So sorry. I'm looking for the angles over here. What am I talking about? Sorry about that. So the data we're looking for here, let me erase something here, right? So we are looking for actually this one. So about this place, okay? So we are looking for the place of y. So how much is looks like it? Isn't it up to 3? Can I say it's about 2 point? Let me see. So it's gonna be 2. Each one is 2 point, about 2.8 or 2.7. So y is in here is about 2.7. Okay. So theta is gonna be the y is a 2.7 over r, which is a 3. Yeah, and then you can just use a calculator to see what it is. So sine inverse of the 2.7 and divide by 3. So it says about 1.12. Without the graphing calculator, plots the value of the 3 times sine theta. Okay, so 3 times sine theta, it's the same as 3 times, but I told you that the sine is the same as r, the y over r, isn't it? So 3 times. Now you're looking for the y, which is y is a 2.7 over 3, and it cancels out as a 2.7. So yeah. Use your answer from the part B to approximate the value of the sine theta. So sine theta, it's just the y over r. So y is a 2.7 over 3, which is about 0.9. Without the graphing calculator, same as a cosine 2. So 3 times cosine theta, which is a 3 times x over r. So 3 times, but the x over there is, you can drop it here. You can drop it here. And then it becomes about 1.25 over 3, which is about negative, so negative 1.25. And then in order to find out the cosine theta, just the x over r, but x is a negative 1.25 over 3, and then it becomes 0.42. Alright, so that'll be all for this investigation.